Today we shall see what percent yield is and how to calculate it. It's a pretty simple concept if you understand what percents are and understand stoichiometry. Percent yield. So, here's what stoichiometry does. Stoichiometry tells you actually how much product can be formed. It tells you the most, it tells you the maximum, it tells you the best case scenario. Under ideal conditions, if all of the product is made and captured and measured, this is what it will be. So it gives you the best case scenario. It tells you what you should expect. It doesn't necessarily tell you what you'll get, it tells you what you should expect to get. We call this the expected yield. The analogy I would like to make is like with grilled cheese sandwiches. If you were actually cutting up the bread yourself, we might measure a loaf and figure out that the loaf should make this many sandwiches, but as we cut it, you know, crumbs are formed and some of the bread is lost due to crumbs, and maybe a dog jumps up on the table and eats half of the loaf of bread, and you don't end up making it exactly what you think you should make. Well, these sorts of things happen in chemical reactions as well. Sometimes you will lose some product. Some of it will escape out of a tube, or maybe not everything will react inside of the tube, and so there'll be some leftover reactants that didn't completely go to fruition. Imagine burning a log. If you burnt a log, we would expect to make this much carbon dioxide, but if part of that log didn't burn, if some of the some of the fire never got to the inside part of the log or something, you might not make as much carbon dioxide. And so stoichiometry tells us the expected yield. It tells you what we should make. So the key here is that expected yield comes from stoichiometry. But then you have something else. You have actual yield. Actual yield is how much you actually make. It's pretty simple. Even if we were supposed to make 100 grams, if we only measured 12 grams, then our actual yield is 12 grams, not 100. It's not calculated. You cannot calculate actual yield unless you are told the percent yield, of course. But it's measured. It's an experimental value. It's an empirical value. It's something that you will get in the lab. This is actually, we're talking about this before a lab because we are going to do a lab and we're going to have to measure what percent we actually get. So if you're doing a problem set involving percent yields, this would be probably given, might be given depending on how the problem is worded. So you have expected yield that comes from stoichiometry, and you have actual yield that comes from the actual experiment. So what about percent yield? Well, percent yield is this. It shows how much of what could have been made was made. It's a ratio. So did I get 100%? If I was supposed to get 12 grams and I got 12 grams, I got 100% yield. But if I got 6 grams, that's 50% yield. And so that's how it works. So how do we just do that? Well, how do you find the percent yield? To find the percent yield, you take the actual yield, how much you actually got when you ran it, the experimental value, and you'll divide that by the expected value. And the expected value comes from stoichiometry. And then, like with all percents, we then take it times 100. And that will give us the percent yield. So again, the actual value is the measured amount, and the expected value comes from the stoichiometry problem. And that is how you calculate percent yield. And because sometimes it's simpler to have nice little symbols for things, and when you're solving for variables, sometimes it's easier to not have big long words there. I've kind of reduced the formula to this. Percent equals A over E times 100. A is the actual value, and E is the expected value. Sometimes these are referred to as experimental yield is the actual, and theoretical is the expected. So if you ever see those words anywhere on a standardized test or something, that's what those mean.